Okay, students, now we are going to state the Newton's second law of motion. Before that, we must understand one new concept, namely momentum. So, to study the Newton's second law of motion, we must understand the concept momentum, which is denoted by the symbol small p. And this is a vector. This is actually a vector quantity which has both magnitude as well as direction. Now, what is the meaning of the term momentum? Momentum is actually defined as the quantity of motion associated with the body. The quantity of motion associated with the body. Now, you compare a two-wheeler and a car. Both are going on a same road in the same direction parallel to each other. A bike is having less mass than that of a car. Suppose if both bike as well as car have to be stopped, brake should be applied. So to stop the car, the opposing force called the brake is required, which is greater than that for a bike. To stop a bike, how much force is required is less than that required for the stopping of the car. Why? Both are going with the same speed only now. Same brake should be sufficient to stop both the bike as well as the car. What is the difference between the bike and the car? Because the quantity of motion associated with the car is greater than that of the bike. Though their velocities are same, but their masses are not same. So, my dear students, momentum is numerically or mathematically defined as the product of mass and velocity. So, the brake required to stop a vehicle does not depend only on its speed. It also depends on its mass. You compare a road and a railway track are parallel to each other. A car is going at a 60 km per hour and a parallel track, a train also is going at the same speed of 60 km per hour. Suppose if same force is applied to both the train as well as the car, okay, car will stop almost immediately, but the train will move over a kilometer or and ahead of that, and then only it will stop. Why? Because stopping the train requires a greater force, is it not? Because lot of momentum or lot of quantity of motion is associated with the train. This quantity of motion associated with the moving body only is called as a momentum. Okay. So, momentum is numerically, that is the magnitude of momentum is the product of mass into velocity. Mass into velocity. Okay. This is a vector quantity I told you in vector form. In vector form, if you write means then P vector is equal to mass into velocity vector. This shows that the direction of the momentum will be along the direction of the velocity of the body. But we are not going to indicate every time the vector symbol. We are going to use the scalar form of this equation only. Okay, students. So the unit for mass is kilogram and the unit for velocity is meter per second. Therefore, what is the unit of momentum? The unit of momentum is kilogram meters per second. Okay, students. So, momentum is numerically equal to, or it is defined as a product of a mass of a body and its velocity. Now, shall we go to the Newton's second law of motion? Okay. In this picture, you will see that I have considered a body of mass m, which is having a velocity, initial velocity u. Okay. So, what is the momentum of the body here? Can you tell me? If m is the mass of the body and u is the initial velocity, means then its initial momentum can be represented as pi for initial. So, this is the product of mass into initial velocity u. So, the initial momentum of the body is pi is equal to mass into initial velocity. Okay, students. Now, a force is going to act from behind. So, I am going to push this by applying a force F. When a force F is applied, imagine your friend is going forward in a bicycle. If you go from behind and push the carrier of the cycle means his speed will increase or not. His velocity will increase. So that depends upon how much force you give. Slightly if you push means then the increase in velocity also will be very less. Very harshly if you push means what will happen? Then he will pick up a great velocity and he will go in the forward direction. So it all depends upon the magnitude of the force. Okay students, now do you agree that when I apply a force from behind the body of mass m, will the velocity of the body increase or not? So it will attain some other velocity which is greater than the initial velocity u. So I am going to call that as the final velocity. So as a result of this force, now the body is moving in the forward direction like this, so that its velocity has increased in the same direction with different magnitude. So this is the body now. So what is the velocity initially is u. What is the velocity after the force has acted on the body is v. So v can be taken as the final velocity of the body, and hence its final momentum is denoted by p suffix f. So this is equal to mass of the body into final velocity. Okay. So what is the initial momentum before applying the force? That was denoted by p initial, pi, that is equal to m into u. Then after the force has applied on the body, now the velocity of the body has increased, so that its final momentum has now increased, which is denoted by Pf is equal to mass into final velocity. So what is the change in velocity? V minus u. So change in velocity, I will write change in velocity is equal to v minus u. Therefore change in momentum is what? Change in momentum must be final momentum minus initial momentum. So P final minus P initial. So this is equal to, instead of P final, m into V, minus instead of P initial, m into U, and this is equal to m into V minus U. Okay students, now you tell me, a force has acted on the body, and this force may be a very small force which is acting for a short interval of time, or a long force, a greater force which is acting for a long interval of time. So the change in momentum will take place in a definite time t, is it not? So how long the force is acting on the body, so long will there will be a change in the momentum of the body. So whenever the momentum of the body changes means it should have consumed some time. So the time interval for which the force acts, the time interval for which the force acts is denoted as what? Small t. So for a small time t only, the momentum of the body has changed from mu to mv. So if you divide the change in momentum of the body by the time interval, that is called rate of change of momentum. Therefore, rate of change of momentum. So this one is the rate of change of momentum. I will write the symbol like this, okay? P, that is equal to m into V minus m into U divided by T, that is m into V minus U divided by T. So this is the rate of change of momentum. So who is the cause of this change in momentum? Who has produced this change in momentum? It is the applied force. If the applied force is small, then the rate of change of momentum also will be small. When the applied force is very large, then the rate of change of momentum must also be very large or not. So are they depending on each other directly? This dependence on the applied force and the rate of change of momentum only is called as Newton's second law of motion. Okay students? So this force which is responsible for the change in the momentum of the body is called as applied force, or I will write so this applied force is equal to F. This only is responsible for the change in momentum of the body. So this applied force and the rate of change of momentum are directly proportional to each other. This is the statement of Newton's second law of motion. So force is proportional to dp by dt, that is rate of change of momentum. Mathematically dp by dt we write, but how to read this is what? A rate of change of momentum of the body. So this is proportional to m into v minus u divided by t. Okay. But the final velocity v minus initial velocity u divided by time, already we have studied, that is called as what? Acceleration, is it not? So I will write f is proportional to m into a, because v minus u by t is equal to a, that is the acceleration of the body. Understand? Therefore, my dear students, f must be equal to some constant k times m into a. So this is the mathematical format of the Newton's second law of motion, where k is the constant of proportionality. I told you, if less force acts means less acceleration only will be produced. If large force acts means large acceleration will be produced. But the physicists have proved that if the mass of the body is 1 kg, that is a unit mass, to produce 1 meter per second square acceleration, that is unit acceleration. So to produce unit acceleration in a body of mass 1 kg, how much force is required they have calculated. It was just 1 Newton. Therefore, the K, constant of proportionality K, is equal to 1. It was proved. Therefore, we can write now force is equal to mass into acceleration. So this is the mathematical form of Newton's second law. Force is equal to mass into acceleration. Okay, students. Now, in words, we can write the same and remember forever. So, force is the product of mass and acceleration. This is also called as the numerical definition of force. First law defines force, we have studied, is it not? It gives the definition of force. But the mathematical definition of force is given by which law? Means that is the second law. So this is called as the mathematical definition of force. Now this applications of this Newton's second law in our everyday life we are going to discuss. So what are all the applications we are going to see now? Have you ever seen the greatest catches in cricket matches and all? In cricket match, sometimes the catches of the ball you must have observed. Suppose if the ball is coming in the air, they will not catch there itself. They will lower their hand like this. They will lower their hand like this to collect the ball. Have you ever observed or not? This is a beautiful example. Okay, I will tell you why they are lowering the hands. You see this equation, force is equal to mass into acceleration. So this force is equal to mass into, instead of acceleration, v minus u by t I will write. In this equation, t is the time taken. Suppose if the object is coming in the air and you are catching there itself, means quickly you are catching the ball. So that the time interval is very short. So that when the time interval is very short means then the average force exerted by the ball on our hand will be greater. Okay, now what will happen if you delay the catch? Slowly, if you lower your hands and somewhere you collect the ball, means in this duration of time, okay, t can be increased or not now. When you delay the catch, t gets increased. So when the t in the denominator gets increased, means automatically the average force exerted by the ball on our hand will be reduced. Okay, students? So that this average force exerted on our hand will be reduced. Now in the same equation, this implies a force into time taken. This is equal to mv minus mu. Is it not? I can rewrite the Newton's second law in different forms like this. So force into time, this product F into T is equal to final momentum mv minus initial momentum mu. This in your higher class you are going to study that the product of this force and time taken only is called as impulse. Impulse of the force. So what is meant by the impulse created by the force? The impulse caused by the force is defined as the product of the force acting on the body and the time for which the force acts on the body. Is it not? So my dear students, from this equation F is equal to m into A, I can write F is equal to m into V minus U by T, or F into T is equal to mv minus mu. The left side product of force into time is called as impulse of the force, the impact or the impulse caused by the force. And force is in Newton, time is in seconds. So what must be the unit for impulse now? F is in Newton, T is in second means then the impulse is having a unit what? Newton into second, N into S. But what is on the right hand side of the equation? mv minus mu, which is change in momentum. Change in momentum is having the unit of what? Kilogram meter per second. So kilogram into meter per second. So impulse is having two units. One unit is Newton second. The other unit is what? Kilogram meter per second. So my dear students, what is the statement of Newton's second law of motion we are going to summarize? So according to Newton's second law of motion, the rate of change of momentum of a body is directly proportional to the force, applied force, okay, acting on the body. So F is proportional to dP by dt, and instead of P, V minus M into V minus M into U by T if you substitute means finally we are arriving the equation F is equal to M into A. Okay. Hence from Newton's second law of motion we have proved that mathematically the force acting on the body is the product of its mass and acceleration. So first law defines force and second law gives the mathematical definition of the force. Have you all understood? We are going to the next Newton's third law.